Hello everyone, welcome to our next lesson. We're going to start the third conic section in today's lesson, and this conic section is called the ellipse. It actually, if you look at the graph, kind of looks like a circle. It does have a center, but it looks like it's been squat a little bit, like someone stepped on it perhaps. All right, well, if that's the case, it's not perfectly round. We call that an ellipse. So if you look carefully at this ellipse that they've got drawn, this is on page 17, by the way, in your notes. The definition of an ellipse is the set of all points in a plane, so they use the word coplanar, such that the sum of the distances from two fixed points is constant, and those fixed points are called the foci of your ellipse. So if you look carefully at this ellipse that they've drawn here, now you can see that this ellipse, it doesn't look circular obviously, but it's what we call elongated horizontally, something like this right here, something like that. And if that's the case, then the line that joins the two furthest points that are furthest apart, like right here, those are called the vertices, by the way, the two points that are furthest apart because it's elongated horizontally. Those are called the vertices. And joining the two vertices, we have a line called the major axes. Now, if your ellipse was elongated vertically like this, then your vertices would be at the top and the bottom, and then your major axes would be a vertical line segment, okay? The two foci, or singular would be focus, the two foci always lie directly on the major axes. On either side of the center, the same distance away from the center. Well, according to the definition, if you take any point that's on the parabola, like right here, this point xy, if you were to add this distance 1 plus this distance 2, it's always a constant. All right. In fact, that you would use that property sometimes to come up with certain equations to solve certain types of problems involving your ellipses. Now, some other things I'd like to point out as well. We just mentioned the major axes and the two foci. The 2 points that are closest together would be these two right here, and they would sort of lie on a line segment that's perpendicular to the major axes. And that would be like this if your ellipse is elongated horizontally. Those 2 points would be located here and here if it's if it's elongated vertically, and they're called the covertices. Covertices. So there's one, and there's the other, and they're important as well. All right, they're important points. If excuse me, if you were graphing this ellipse or trying to find out the solutions to certain problems involving ellipses, getting those points would be important. Um, the line segment that joins the two covertices together is what we call the minor axis. It's actually like the shortest axis that you can draw passing through the center inside of an ellipse. All right. So those are the main parts of an ellipse. You have your vertices, you have your covertices, you have your center, and you have your two foci. And joining the vertices is the major axes. Joining the covertices, we have the minor axes. All right. Now, something else I'd like to point out. There are some letters involved here. They actually use certain letters to indicate certain distances. The distance from the vertex to the center, they always use the letter A for that. Okay, so just remember that the distance from the vertex to the center is your A, and by golly, that's another A over there. So if you look at this carefully, if you look at your diagram, then it just makes sense to say that the length of the major axis is actually 2 times A, isn't it? That's the length of your major axis. The distance from the center to a covertex, they actually call that B. All right, and you will see B in your equation now in just a moment when we look at them. Here is another B down below, same distance away from the center. So it, again, would only make sense to say that the length of the minor axis is equal to 2b, whatever that is, all right? Now, like I say, you will find your a's and your b's from your equation in just a moment, two very important measurements. Now, there's another letter they use here for another distance, and you can probably tell what that distance is going to be. The distance from the center to either one of the two foci, they call that C. And of course, that distance right there to the other side, that's also C. And C will not show up in your equation. You don't see the C's there, but to calculate it is actually pretty straightforward. Excuse me. And here is the relationship between A, B, and C, right? Now, this is on page 17, like I say, about halfway down that page. Look at that right there. You see that? That's the relationship between A and B and C. You'll find the A and the B in your equation, like I said, but the C you will have to actually calculate. We're going to need that. All right, so that's what the ellipses look like. What about their equations? Well, have a look. Here's the two types of equations that you could end up with. Notice that just like a circle, the x is squared and the y is squared. All right. They're added together. The signs must be alike. Now, the form that you usually see ellipses in, they have denominators. All right. There are two numbers in the bottom, usually. And those two numbers, that's where you get your A and your B from, because one of them is A squared and the other number is B squared. And how do you tell which one is A and which one is B? Well, it turns out that A squared is always the larger of the two. So whichever one of those two numbers is bigger, that's your A squared. The smaller number then, in that case, would have to be the B squared. Now, if the A squared is under the x squared term, like in this first case, then that means that your ellipse is elongated horizontally. All right? It looks something like this one right there. If your a squared is under the y squared, now notice they've written the y squared term here first. I usually don't write them like that. I usually always write the x squared term first. You don't have to, but that's typically the way I do it. But if the larger number is under the y squared, then your ellipse is elongated vertically. And you'll notice in that case your major axis is vertical, your minor axis is horizontal, and so on. All right? That's important to remember as well. And the center of your ellipse, we're still calling it HK. Well, you get the center of your ellipse in exactly the same way that you get the center of your circles. All right? You look at the number behind the X first, always behind the X first. Whatever that number is, you change its sign. That's the X coordinate of your center. And the same thing with the Y. You look behind the Y secondly. Whatever number is behind that Y, you change the sign, and then you call that the Y coordinate of your center. And basically, that pretty much describes what their equations look like. But again, notice that the x is squared and the y is squared. You have two different numbers on the bottom. Oh, there's a good point. What would happen if those numbers were the same? What if there was no larger number? What if you had x squared over 4 plus, and then you also had a y squared over 4 and something else? Well, it turns out that this thing is not an ellipse. That's actually a circle. All right? So if you have numbers in the denominator, if they're alike, you have a circle. If they're different, then you have an ellipse. So that's an important point as well. Let's, oh, yes, here, look at this on the bottom of page 17. You don't see this very often, but there's something, the measurement basically, it's sort of the measurement of how stretched out an ellipse actually is. How elongated is it? And it's called the eccentricity of an ellipse. And it's a very simple equation, very simple formula for it. The eccentricity, they use the symbol E, not to be confused with the base of the natural logarithm. They just call that C over A. All of these equations, by the way, all right, for eccentricity, these equations right here, which I call them the standard form of the equation, and C squared, they're all provided on a formula sheet. You don't have to memorize those formulas. All right. Now let's start. We're going to actually do some of these examples now, beginning on page 18 and also page 19. All right. We have to get these looked at. And remember all those different relationships that we saw for an ellipse. So let's start with part A. Part A is actually pretty simple. We have an ellipse that says x subtract 3 squared over 25 plus, and then y plus 2 squared over 9 is equal to 1. Now I know this is an ellipse because I can see clearly the x is squared and the y is squared. I can see they're added together, and the numbers in the denominators, one's a 25 and one's a 9, they're different. And something else I should point out, that if you write the ellipse in this form, it's always equal to 1 on the right-hand side. Always 1. All right? And that's so you can get your A's and your B's and work out your C's. Now, getting the center is actually straightforward. The center for this ellipse is going to be, well, look behind the x. We have a minus 3, so it's going to be positive 3. And look behind the y. You have y plus 2, so the y coordinate of the center is going to be negative 2. There's your center. In fact, if you made a rough sketch of what this looks like, and you probably should make a rough sketch, especially for part C. All right, watch this. Your center is 3, bloop, 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 3 to the right and 2 down. So there's your center right there. Okay, I'll even put a little, no, I won't put a C there. I'll just put the dot there. I'll tell you what, I'll put an O there, kind of like the center of a circle, but it's not a circle. But then now part B, anyway, that's my center. What is A, what is B, and what is C? Well, remember that you get your A and your B directly from your equation if it's written in that form. A is always the square of the larger number. So A squared, there's my A squared right there. It's 25. Here's my B squared. All right, B squared. So that's the smaller of the numbers. And something else I can now tell, because the bigger number is under the x squared, this ellipse is going to be stretched out horizontally. Something like that right there. Okay? So my A and my B and my C. Well, let me see. Well, if A is squared is 25, then I just take the square root of that and I get A equals 5. You're not always going to get a nice whole number or an integer, but in this case we do. You can leave them as radicals if you want, or decimals if they're not perfect squares. B squared is equal to 9. Okay, that's the smaller number. So I take the square root of both sides there, and I get B is equal to 3. There's my B. Now remember, C you won't find in your equation for the ellipse, but you can easily calculate it by using C squared equals A squared minus B squared. Make sure you show this calculation, by the way, if you ever need to use it. So let me see. Now A squared was 25, and B squared is 9, so I subtract 9, and look at this. I get C squared is equal to 16. Oh, that's a perfect square as well. That doesn't happen often. But if you take the square root of both sides there, you get C is equal to 4. Okay, so there's my A and my B, and yes, I had to calculate my C. If that was not a perfect square for C squared, you could either write C as a decimal or even leave it as a radical as well. Now, here's part C. Find the foci, the vertices, and the covertices. Now, the whole key to getting this is a very rough sketch of my diagram. I know that it's stretched out horizontally because A squared, the bigger number, is under the x squared term. So here is my major axis, oops, something like that. My covertices and my vertices are located as so. To get my foci and my vertices, I have to go left and right from that center. Left and right. Okay, so here's my center. I go to the left to get this vertex. I go to the right to get this vertex. And also my foci, which will be somewhere in here, somewhere on that major axis. I go up and down to get my covertices, right? Now remember, the A and the B stands for something, and so does the C. A is the distance from the center to each of the two vertices. Okay? Now remember where my center is. It's actually at 3, negative 2. I'll tell you what. Let me put 3. Let me put 3 and negative 2 there. That's my center. All right, so if you want to get your vertices, watch what you do. And actually, there's not even really workings for this, as long as you have your diagram and as long as you move the correct number of spaces in the correct direction. So to get my vertices, That's A units to the left and the right in this case, A units to the left and right of the center. So if I went from 3, -2, if I went 5 to the left, I'd end up over here somewhere. And just subtract 5 from that x coordinate, from that 3, and you're going to get -2, -2. There's one vertex. And the other one I'd go 5 units to the right from 3, 2, and I'd end up over there somewhere. Okay, something like that. So I just add 5 to the 3, and I will get 8, -2. There's my vertices. Okay, there's my vertices. -2, -2, and 8, -2. Well, what do you want to get next? You want to get the covertices? All right, let's get the covertices. Now remember, in this case, because my ellipse is elongated horizontally, I have to go up and down from my center. B units. And B, according to our calculation, is 3. So from 3, -2, I have to go 3 up, and I'll end up approximately there. And I have to go 3 down, and I'll end up approximately there. What you're really doing is adding and subtracting 3 to and from the y-coordinate, you see? And the y-coordinate was -2. So if I take 3, -2, and subtract 3 from the y, I'm going to get 3, -5. And if I add 3 to the y-coordinate, to that -2, I'm going to get 3, 1. All right, and you can see from my diagram, if you had a piece of graph paper, you could even be more specific. You could be more exact. I'm just making a rough diagram here. Okay? And now the other thing they want us to get the two foci. All right, so here we go. Now again, because of the way this ellipse is elongated, it's elongated horizontally, we have to go left and right from the center, whatever C is, that many units, that many blocks, all right? So in this case, you're going to have, let me see, 3, -2. So again, you add and subtract the 4 to the x-coordinate, the 3. So that's going to give us -1, -2 for one of my two foci. And if I add 4 to the 3, the x-coordinate, I get 7, -2. And there's my two foci. But keep an accurate diagram here. The more accurate you have that, the better. In fact, in a lot of cases, sometimes I've actually put just a blank piece of graph paper on a test or on a quiz so that a student can work this out fairly easily. Now, part D says, what is the eccentricity of the ellipse? Well, remember the eccentricity is C over A. That's your eccentricity. And I've already worked out my C. It's actually 4. Okay, so I'll write a 4 there. You can leave this as a fraction if you have a fraction. So if they're radicals, you can leave them as radicals, or you could write it as a decimal. And C is 5. All right, so 4/5, 4 over 5. Your eccentricity is always going to be less than 1, by the way. It's always going to be less than 1, okay? If it's ever bigger than 1, you've done something wrong. If you leave it as a fraction, just make sure you reduce it as much as you can. And there you go. There's example number 1 done. All right, a little bit of work to it, isn't it? But practice makes perfect, remember. Here we go. Here's number 2. Here is number 2. Well, this one is a little easier because if you look at it carefully, do you notice that you just have x squared and y squared? There's nothing added or subtracted to the x before it's squared. There's nothing added or subtracted to the y before it's squared. And that tells me right away that the center of this ellipse, and I'll write that right here, the center in this case is actually 0, 0. All right? It's very similar to what you would do for a circle. So here's my rough diagram. Oops, something like that. Well, by golly, there's my center right there. Okay? And I can also tell that it's an ellipse, okay, because they're both squared. The numbers in under are different and they're added together. Now this time you'll notice that a squared is the 36. It's under the y this time. And that means that this ellipse, when you're all said and done, this ellipse is going to be stretched out vertically, something like that. And that means that from the center now, to get your vertices, you have to go up and down. To get the foci, you have to go up and down because your major axis now is that line. You see, there's your center, And there's one vertex at the top and another vertex at the bottom. Your foci are somewhere in the middle, somewhere between the center and the two vertices, and your co-vertices will be left and right. I'll just put a CV there and a CV there. There's your two co-vertices. All right, that would be your B. Anyway, let's see. What do you want to get next? Do you want to get your vertices? All right, let's get our vertices. Now I need to calculate my A and my B first. So let me see. Let me just come up here and I can see that A squared is 36. So that means A is equal to 6. By the way, what's the length of your major axes? It's 12. 2 times A, isn't it? The B squared is 4. So if I take the square root there, I get B is equal to 2. And that's going to be the distance from my center to both of my co-vertices, right? Left and right. So the vertices, now you can see that A is 6. All right, so what I do from my center here, I go up 6 to there, and I go down 6 to approximately there. And that's one vertex, and that's the other vertex. Now remember, if you go up and down from a point from the center, you're adding and subtracting to the y coordinate, not the x. So I have to go up and down 6. So let me see, how about 0, negative 6? That would be the one there on the bottom. And if I go up, I'll have 0, positive 6. That's the one on the top. So there's my vertices. If you were asked to graph this this ellipse, if you were asked to graph it, those points are vital. You would have to put those in definitely. Okay, so what about the co-vertices? Now remember that in this case, that would be left and right from the center. B units. So there's my B. Look, B is 2. So I go 2 to the right, and I end up approximately there. There's one co-vertex. And I go 2 to the left, and that would be approximately there. There's my other co-vertex, right? It's elongated vertically this time. So if I go 2 to the left and 2 to the right from 0, 0, by golly, I'm pretty sure that's going to be negative 2 and 0. And that's going to be positive 2 and 0. All right, there's my co-vertices. There's my co-vertices. You can see what the shape of your ellipse is kind of going to look like. Something like that right there, you see? Now my foci, I need my C. All right, so let me see. I've got to work out the C squared. C squared is A squared minus B squared, which in this case, I don't know if we're going to end up with a nice whole number this time. You've got 36 is your A squared, B squared is 4, and by golly, that gives you 32. All right. Now, what do you want to do? Do you want to leave it as a radical? Because if you did, you would call that root 32, which simplifies into 16 times 2. That would be 4 root 2. You could leave it as a radical if you wanted to, or you could say C is equal to, now as a decimal, what's that as a decimal? Let me get my calculator. 4 times 1.414 approximately. So 4 root 2 is actually about approximately 5.7. One decimal place is fine. One decimal place is fine. Now, that's the distance that you have to go up and down to get your two foci. So if you used your radicals, if you left it as a radical, that's okay. You can do that. Most people, I think, most students prefer the decimals, and that's all right. You can use the decimals if you want. So if you use the decimal, and if you go down 5.7 blocks from the origin, you're going to have 0, comma, minus 5.7. That's going down. If you go up, you're going to have 0 and positive 5.7. All right, so that would be your two foci in this case. Or if you had left it as, watch, if you left it as a decimal or as a radical, sorry, if you said 0, negative 4 root 2, that's okay. And then the other one would be 0 and positive 4 root 2. If you want to leave them as radicals, you can. But like I say, most students prefer to leave them as, or to write them as decimals. But they could be radicals. All right, what else have we not done? We've got the center. I found the vertices. Now, I also found the co-vertices. I found out that most of these questions don't ask for the co-vertices, but I think that's important. You should put the co-vertices down as well. Oh, look, the eccentricity. We don't have the eccentricity yet. And again, if you want to write the eccentricity as a fraction or a decimal, you could even leave it as radical. 4 root 2, that's my, no, that's my c. C over a, remember? Actually, I should write that equation first, just to make sure you don't forget what it is. It's c over a. So the c, you could call that 4 root 2 over, and the a was 6. Now, if you left it like that, of course, you'd reduce it to 2 root 2 over 3. But there's nothing wrong with giving it as a decimal either. What would that become? If you just said 5.7 divided by 6, that's pretty close. That's about 0.95. Notice that it's less than 1 again, isn't it? All right, so that's number 2 done. Number 3, I'm just going to point out down there on the bottom, is much the same. Let me see. The first thing I noticed, though, it's definitely an ellipse for number 3, because I can see the x is squared and the y is squared. They're added together, but they've got different numbers. Now, notice this time the different numbers, though, are in front. They're coefficients. They're not in the denominator, but that's still an ellipse. If those numbers in front were the same, by golly, you'd have a circle. Now, the one thing that's a problem with this one, everybody, is that, well, first of all, you've got numbers in front, all right, but look, there's the main problem. That's 600. You need that to become a 1. So what you should do here is divide, first of all, everything by 600. Everything. All 3 terms. And now reduce as much as you can. 2 over 600 actually becomes x squared over 300. Right? That just reduces like a fraction. And then I have a plus. And now 3 over 600, well, that will reduce to y squared over 200. Aha, now I can see which one is a squared and I can see which one is b squared. And that's equal to 1. All right. There's my a squared. Now you're not going to get a nice whole number this time when you find your a. Here's my b squared right there. Okay. So I can tell that this ellipse is going to be stretched out horizontally like so, which means that my vertices are going to be left and right. There's one vertex, there's the other, of the center. The center is just 0, 0 for this one, by the way. The co-vertices are going to be up and down, like so, from the center. And because this is my major axes, my 2 foci, one is going to be approximately there and the other is going to be approximately there. They're going to be left and right from the center. Okay? So this one, I think I'll leave this one for you to try. Remember, the solutions are on D2L. If we get an opportunity in class, I may finish this one as well. But if you look carefully at question number 2 and what we did there, really question number 3 is not that much trickier, well, except for the fact that you may have decimals for A and B. But except for that, that's about it. So I'm going to leave that one for you to try. Now, let's go to page 19. And here is one where they're asking you to draw the graph. They want you to sketch the ellipse. And again, I can clearly see it is definitely an ellipse because the x part is squared, the y part is squared, and they're added together. And now these 2 terms have denominators, but the denominators are different. Okay, that's good. That means this is definitely going to be an ellipse. If those numbers in the denominators were alike, remember, and everything else was exactly like it looks, then you'd actually have a circle. And it's equal to 1 over on the right-hand side. That's good. We have to have that in this form. Now, they want us to sketch the ellipse this time. That basically involves everything that we've done on the previous page, locating the vertices, the co-vertices, the foci, things like that. And we'll include the foci, by the way, for the graph. We don't need the eccentricity, though. All right. Now, I'll tell you what. Let's look at that first of all very carefully. And I can see that the larger of the 2 denominators is under the x squared term, which means that tells me, everyone, that this ellipse is going to be stretched out horizontally. Now, that's important. That's actually vital for locating my vertices and my co-vertices and my foci. The center, let's plot that first, shall we? The center is actually at -2 and +3. There's my center. So -2, +3. How about right there approximately? Okay, I'm making a red dot there. As good as I can with this stylus I've got. There's my center. All right, now let me see. A squared is 16. I'll just jot that up here. A squared is 16. So A is 4. Remember, A squared is the larger of the two denominators. B squared is equal to 4. So B is the square root of that number. B is actually equal to 2. Now remember, if my ellipse is elongated horizontally, there's my center. I go A units to the left and right to get my vertices. Well, there's my A. Look at that. My A is 4. So I just need to, from the center, count 4 blocks to the right. Let me say 1, 2, 3, 4. So there's one of my vertices. And they go 4 blocks to the left. 1, 2, 3, 4. And there's the other of my 2 vertices, right? 4 to the left and 4 to the right. In fact, you could even write them down if you wanted to. All right, over here, the vertices in this case, and you can just count your squares now. How about -6 and 3? There's one. And the other one now to the right of that center was at +2 and 3. There's my 2 vertices. See that? And I just graphed them. I just went left and right because of the direction that this ellipse was elongated. Now, co-vertices would be up and down in this case. B units from the center. Well, by golly, look at that. There's my B. So from my center again, I'll go 2 up, and I'll get a point approximately there. There's one co-vertex. I'll put a V there and a V there. And I'll put a CV there for my co-vertex. And I go 2 units down, right to there. And there's my other co-vertex. Okay? You know what? You could draw that ellipse right now. You could draw that right now as good as you're going to, freehand. So my co-vertices, well, that looks awful. My goodness, I wish I had a nice stylus. My co-vertices are going to be -2 and 1. I mean, you could just read the coordinates off from your graph now. -2 and 1. And let me see, it's also -2 and 5. And there you go. There's your co-vertices. All right? And like I say, you could draw the graph right now as good as you're going to be able to draw it. As well as good as I can draw it with my stylus. But we also need to include the foci as well. All right? They should be included in any graph that you draw. So to get my foci, I need my c squared. So let me see. C squared is going to equal a squared minus b squared. So in this case, that would be, let me see, a squared is 16, b squared is 4. So you're going to have c squared equals 12. All right, now you may as well get this as a decimal, because remember, you have to go up and down that many units, or sorry, not up and down, left and right, that many units from the center. So let me just take my handy dandy calculator here, and let me just find out what the square root of 12 is approximately as a decimal. I get 3.46, so I'll tell you what, why don't you call that about 3.5? One decimal place is fine. So from my center, I go 3.5 blocks to the left. Ooh, now that's really, really, really close to the vertex. In fact, using this stylus, you might not be able to see it very well, but it's about right there. Look, and I'm going to put a little letter F beside that focus, and 3.5 blocks to the right. It's only half a block away from the vertex. But you know what? That stuff happens. There you go. But at least it's inside. It can't be outside. And now, as carefully as you can, take your pencil or your pen, whatever you're using, and you try to make it nice and smooth now, nice curve. No diamonds. These are not diamond shapes. These are nice and curved. Something like that. Now, with my old stylus, that's about as good as I can get it. But if I had an actual piece of graph paper and a nice pencil or pen, I'd make it a lot nicer looking than that. But there's your graph. And if you wanted to write down the coordinates of the foci, remember now you moved 3.5 left and 3.5 right from that center, right? And the center, remember, was at -2. So if you go 3.5 blocks to the left, you'll get negative approximately 5.5 and 3. And the other one now, if I go 3.5 blocks to the right, you're going to end up with about positive 1.5 and 3. So there's your two foci. But we drew the graph, okay? And remember, it all depended on, first of all, recognizing which direction it was elongated in. Okay? This is a long video, isn't it? This is a bit of a long one. Okay, now the example down in under that is actually pretty good as well. We'll do this one. Number 2, I'm not going to go ahead with number 2, not on the videos anyway. I may show you this one in class, but number 2 is a really tricky one. Okay? They're asking you to find the equation of the ellipse. They're giving you a foci. Oh no, actually that one is fairly straightforward. Where's the one that's tricky? No, it's not that one. Oh, I think that one comes up later. Oh yeah, that's right. That's not it. Let's try number 1. Find the equation of the ellipse with a center at 0, 0. I'm just going to make a rough graph. In fact, on a quiz or a test, I'd probably include a graph for you here to make sure you get this nice and accurate. So the center is at 0, 0. Okay, kind of like that. One of the foci, one focus is -5, 0, and that's way over there. Okay, so there's one focus. Now remember, that's not the vertex, that's the focus. But what it does tell me is that this ellipse is elongated horizontally. And a vertex is at -7 and 0, 0. Or, sorry, oops, come back. -7 and 0. I just lost my graph there then. Lost my diagram. So that's kind of there. Now that tells me two things. That tells me my A is 7. The distance from the center to that vertex, right there, A is equal to 7. I'll just jot that down. It also tells me what my C is, because that's the distance from the center to the focus. So C is equal to 5. The center is at 0, 0. Okay. And because it's elongated horizontally, the larger the number, A squared, that must be under the X squared, isn't it? Now I know the other focus is over here somewhere and the other vertex is over there somewhere, but that's totally irrelevant here now. Okay, so watch what I'm going to do. I know this is going to be, and the center is at 0, 0. That makes it easier as well. It's going to be in the form x squared over a squared, because remember, it's elongated horizontally. Okay, and then it's going to be plus y squared over b squared, and it's going to equal 1. Look at that. See, that's what it's going to look like. And I know what my a is. Look at that. The distance from the center to a vertex is my a. So that, everybody, is going to be 7 squared. So let me see, x squared over 7 squared. Now you all know what 7 squared is. That's 49. Plus, and then you've got y squared over, over what? You don't know your b, do you? Well, that means we got to do a little calculation. Remember now that c squared equals a squared minus b squared. If you wanted to, you could rearrange this equation to get the b squared by itself. And if I did so, now the b squared I'd put on the left and it would become positive is equal to a squared minus c squared. You see, you can do that first, or you can put the numbers in first. Doesn't really matter. So b squared is going to equal, let us see, a squared we just saw was 49 minus, now remember c was 5, so c squared is the square of that number. So c squared is actually going to be 25. And now, if you just subtract, you get b squared equals 24. Now, remember, that means that b is the square root of that number. But you're not graphing this. You don't need your b in your equation. Oops, I forgot my squared right there. Look, in your equation, you need b squared. So really, you don't need to do anything else except put down what b squared is under the y squared. B squared is 24. Right there. And that's your equation, everybody. That's the equation of your ellipse, given the center, a focus, and a vertex. There's other things they could give you as well, other types of information. to come up with the equation of an ellipse. You'll see some more, don't you worry, in the practice questions that follow. For number 2, let me see. Okay, I'll quickly look at number 2. Wow, this is a long video. Yeah, I thought that one was tricky, but it's not. Find the equation of the ellipse with a foci at 1 and -2, and also 1 and 10. Ooh. And the minor axis is 5 units long. Now watch this, a rough graph. I'm going to try to get through this one fairly quickly. This video is long. I'm going to approximately, with as good as I can with this stylus anyway, put in my 2 foci. Now let me see. I have to go 1 to the right and 2 down. So right about there. Right about there. There's 1 foci. And remember now that's 2 down. Okay, so 1 F is 1, -2. And the other foci is at 1 and 10, so again, that's 1 to the right, but now I go up 10 blocks. So way up here somewhere, way up there, there's my other focus at 1, 10. Now that tells me something important. Remember that your foci are always located on your major axes. So this ellipse is elongated up and down. It's elongated vertically. And that means that the a squared, the bigger number, is going to be under the y squared this time. Okay? That's what it means. Now, I'll tell you something you do need. By golly, you need the center. Look, right in there somewhere. The center is right in between. Now, if this was a proper piece of graph paper, you could just plot your 2 foci and just count your squares. All right? Remember, your center is the same distance from each of your 2 foci. But if you don't have a proper piece of graph paper, what you could do is to get your center, just find the point that's exactly halfway between 1, 10 and 1, -2. Now you know it's going to start with 1, obviously. But what number is exactly halfway between 10 and -2? And that's the same, remember, as finding the average of the 2 numbers. It's kind of like your midpoint, isn't it? In fact, it is your midpoint. So if you want to get your y coordinate, all right, let me just write it down here. Take those 2 y values, one is a 10, the other one is a -2, and if you divide that 2 by 2, so let me see, that's going to be 8 over 2, folks. There you go, that's a 4. All right, and that's 6 blocks from one focus, 6 blocks from the other focus. So it's going to start like this, x minus 1 squared. I like to write the x squared term first always, and that's going to be over b squared, because remember now, it's elongated vertically. And then plus, and now the y coordinate of the center is 4, so that's y minus 4 squared, and that's going to be over a squared is equal to 1. Now, if we can get our a squared and our b squared, we got it. Okay, we got a little problem. Because you don't know your a, you don't know where a focus, or sorry, where a vertex is located. So you can't get your a, not yet. But what about the b? Well, this little thing right there might help us. What about the b? Now, if I went 2.5 blocks. Remember, now the major axis, if it's 5 units long, then that means that the total of it is 5. So if it looks kind of like that, you're really going 2.5 blocks to the right and 2.5 blocks to the left. Well, that means that your b is actually 2.5. Or you could call that, if you want to write that as a fraction, you'd have 5 over 2. That's 2.5, but that's your b. And you know what your c is because that's the distance from the center to a focus. You know that your c is actually equal to, well, just count the squares there. C is equal to 6, isn't it? So watch this. There's my b, so I know what my b squared is going to equal. It's going to be 2.5 squared. But you have to calculate your a. So watch this. C squared equals a squared minus b squared. If you want to get your a squared by itself, just bring your b squared over. So c squared plus b squared equals a squared. So I'm going to leave them as decimals. If you want to use fractions, you can. C squared is 36 because C is 6. B is 2.5. You square that, and I'm pretty sure you're going to get 6.25 equals a squared. Add those together, and you're going to get 42.25. That's a squared there. Now, that's your a squared. And that's what goes in your equation anyway. So watch this. X minus 1 squared over b, remember, was 2.5. But there's a lot to this, isn't it? We call that 6.25 plus, and then this is one of the trickier cases, though, I'm pretty sure. Because of it was made trickier because of the fraction or the decimal. And now a squared was 42.25. Notice it's the larger number, and you write equals to 1. And there you go. There's that one. Yep, that was a long one. That was a tricky one. But they're there, right? That's what you're going to have. Now, notice that on the bottom of page 19, there's a summary there. They show you the two different equations for your ellipses. The center is always located at HK. In both cases, a squared is the bigger denominator. The orientation of the ellipse is found by the variable above the a squared. If the x is over the a squared, then it's elongated horizontally. If the y is above the a squared, then it's elongated vertically. Foci are closer to the center than the ellipses, yes. C squared equals a squared minus b squared. And C tells you how far to move along the major axes from the center to find your two foci, okay? So that's it for this video. My goodness, this was a long video. Right now, I would like you to try. You're able to go ahead and do practice number 1 on page 20. That's okay. Be careful with some of those. They look kind of tricky. Practice number 2 on page 22. I will tell you this, though. On page 22, is this page 22? No, it's still page 21. Okay, so you can try those. They're just graphing. They're fairly straightforward. On page 22, number 3 shouldn't be too bad, but everybody, B right there on page 22, omit that one. I'm going to tell you right now. I mean, if you like a challenge, you go ahead and try it. But I'm telling you, getting that is not trivial. You will never see anything like that on a test from me. All right, you could try it if you want, but I'm telling you, that one is a brute. And also on page 23, I think you can try those questions there as well. Okay. And again, these are finding the equation of the ellipse. So anyway, that's it for ellipses. I know the video was a lot longer than usual, but basically that's it for the ellipses. Now I'm going to go over lots of those examples in class. All right, that we didn't do here. Lots of the practice problems we will go through, and we've only got one other conic section left to go, and that's the hyperbola. So I'll stop there. And I'll bid you a fond farewell. Stay safe, and I'll see you later. Bye-bye.